So antioxidants, believe the hype if you will. I am. Okay. So it's been suggested ultraviolet light induces free radical formation in the skin, which leads to photoaging and cancer. So free radical formation, you don't want any free radical, weird molecules just popping up anywhere, because a free radical could turn into anything. Okay. So we demonstrated by electron paramagnetic resonance that the absorbent free radical is naturally present in unexposed skin at a very low steady state level. When a section of SKH-1 hairless mouse skin in an EPR cavity is exposed to UV light, the absorbent free radical signal intensity increases. These results indicate UV light increases free radical oxidative stress consistent with ascorbate's role as the terminal small molecule antioxidant. The initial radicals produced by UV light would have very short lifetimes at room temperature. Thus, we've applied EPR spin trapping techniques to detect these radicals using alpha 4-pyridyl 1-oxide intert butyl nitrate POBN. We have for the first time spin trapped a UV light produced carbon centered free radical from intact skin. The EPR specific exhibited hyperfine splittings that are characteristic of POBN/acyl radicals AN. So what does any of this mean? I don't know. But it says iron can act as a catalyst for free radical oxidative reactions. So iron, it can act as a catalyst for the reaction, so it can help it like do damage. So iron is bad. Ultraviolet rate from the sun is bad. We've shown in topical application of the sun or the iron chelator, the ferro section of skin reduces the UV loose. I don't know. So antioxidant. It destroys these free radicals, but there's no specific one of those either. So, you know, believe the hype, if you will. I'm gonna go ahead and I got 6 more pages. Okay, so this is gonna be like the next 2 or 3 pages. Just antioxidants. Antioxidants. The body's trillion or so cells face formidable threats from lack of food to infection with viruses. Another constant threat from nasty chemical cells called free radicals. Nasty chemicals. Okay, so they're chemicals. They're capable of damaging cells and genetic material. The body generates free radicals as the inevitable byproducts of turning food into energy. Others in the food you eat and the air you breathe. Some are generated by sunlight's action on the skin and eyes. So the body generates free radicals as the inevitable byproducts of turning food into energy. Others are in food you eat and the air you breathe. Free radicals come in many shapes, sizes, and chemical configurations, but they all share a voracious appetite for electrons, stealing them from nearby substances that will yield them. This electron theft can radically alter the loser structure or function. Free radical damage can change the instruction coded in a strand of DNA. It can make a circulating low-density lipoprotein, sometimes called bad cholesterol, molecule more likely to get trapped in an artery wall. Yeah, which could lead to a heart attack, right? Or it can alter a cell's membrane, changing the flow of what enters the cell and what leaves it. We aren't defenseless against free radicals. The body, long used to this relentless attack, makes squads of molecules that quench free radicals as surely as water douses fire. We also extract free radical fighters from food. These defenders are often lumped together as antioxidants. They work generously by giving electrons to free radicals without turning electron scavenging substances themselves. There are hundreds, probably thousands of different substances that can act as antioxidants. The most familiar ones are vitamin C, right, which is orange juice, vitamin E, which is an E, it's E, beta carotene and other carotenoids, along with minerals selenium and manganese. They're joined by glutathione, coenzyme Q10, lipoic acid, flavonoids, phenols, polyphenols, phytoestrogens, and many more. By using the term antioxidant to refer to substances is misleading. It's really a chemical property, namely the ability to act as an electron donor. Some substances that act as an antioxidant in one situation may be pro-oxidants, electron grabbers in a different chemical milieu. Another big misconception is that antioxidants are interchangeable. They're not. Each one has a unique chemical behavior and biological property. They almost certainly evolved as parts of elaborate networks, each with different substance or family of substances playing slightly different roles. This means that no single substance can do the work of the whole crowd. Antioxidants came to public attention in the 1990s when scientists began to understand that free radical damage was involved in the early stages of artery clogging, atherosclerosis, and may contribute to cancer, vision loss, and a host of other chronic conditions. Some studies showed that people with low intakes of antioxidant-rich fruits and vegetables were at greater risk for developing these chronic conditions than were people who ate plenty in these fruits and vegetables. Clinical trials, something, being testing the impact of single substances, especially beta-carotene and vitamin E, as weapons against heart disease, cancer, and the like. Even before the results of these trials were in the media, supplement and food industries began to hype the benefits of antioxidants. Frozen berries, green tea, other foods labeled as being rich in antioxidants began popping up in stores. Supplement makers touted the disease-fighting properties of all sorts of antioxidants. The trials were mixed, but most have not found the hoped-for benefits. Most research teams reported that vitamin E and other antioxidant supplements didn't protect against heart disease or cancer. One study even showed that taking beta-carotene may actually increase the chances of developing lung cancer in smokers. On the other hand, some trials reported benefits. For example, after 18 years of follow-up, the Physicians' Health study found that taking beta-carotene were associated with a modest reduction in the rate of cognitive decline. These mostly disappointing results haven't stopped food companies and supplement sellers from banking on antioxidants. Indeed, antioxidant supplements represent a $500 million industry that continues to grow. Antioxidants are still added to breakfast cereals, sports bars, energy drinks, and processed foods. They're promoted as additives that can prevent heart disease, cancer, cataracts, memory loss, and a host of other conditions. Often the claims have stretched distorted the data. While it's true the package of antioxidants, minerals, fibers, and other substances found naturally in fruits, vegetables, and whole grains help prevent a variety of chronic diseases, it's unlikely that high doses of antioxidants can accomplish the same feat. Antioxidants are man-made or natural substances that may prevent, delay, or some type of cell damage. Antioxidants are found in many foods, including fruits and vegetables. They're also available as dietary supplements. Examples of antioxidants include beta-carotene, lutein, lycopene, selenium, vitamin A, vitamin C, and vitamin E. So vitamin A, you want to get an A in class. C's are okay. Vitamin C, orange juice. Vitamin E, that's impossible grade. So you got impossible grade, the top grade, and a middle grade, right? So vegetables and fruits are rich sources of antioxidants. There are good evidence that eating a diet with lots of vegetables and fruits is healthy and lowers risk of certain diseases, but it isn't clear whether this is because of the antioxidants, something else in foods, or other factors. High dose of supplements of antioxidants may be linked to health risk. Beta-carotene is a red-orange pigment found in plants and fruits, especially carrots and colorful vegetables. The name beta-carotene comes from the Greek beta and Latin carota, carrot. It's a yellow-orange pigment, gives vegetables and fruits their rich colors. H. Wackenreiter crystallized beta-carotene from carrot roots in 1831, came up with the name carotene. Beta-carotene's chemical formula C40H56 was discovered in 1907. The human body converts beta-carotene to vitamin A, retinol. Beta-carotene is a precursor of vitamin A, the top grade vitamin, right? The best vitamin out there is vitamin A. It's got to be good. We need vitamin A for healthy skin and mucous membranes, our immune system, and good eye vision, or eye health and vision. So beta-carotene in itself is not an essential nutrient, but vitamin A is. Beta-carotene from fruit is a safe source of vitamin A. Vitamin A can be sourced from the food we eat through beta-carotene, for example, in supplement form. The advantage of dietary beta-carotene is that the body only converts as much as is needed. Excess vitamin A is toxic. Toxic vitamin A levels can occur if you consume too many supplements. Beta-carotene is an antioxidant. Beta-carotene, like all carotenoids, is an antioxidant. An antioxidant is a substance that inhibits the oxidization of other molecules or protects the body from free radicals. Free radicals damage cells through oxidation. Eventually, the damage caused by free radicals, by the sunlight and UV on your skin, can cause several chronic illnesses. Several studies have shown that antioxidants through diet can help people's immune systems protect against free radicals, lower the risk of developing cancer and heart disease. Some studies have suggested that those who consume at least 4 daily servings of beta-carotene-rich fruits and or vegetables have a lower risk of developing cancer or heart disease. Which fruits are rich in beta-carotene? The following foods are rich in beta-carotene: apricots, asparagus, broccoli, carrots, Chinese cabbage, chives, dandelion leaves, grapefruit, herbs and spices, chili powder, oregano, paprika, parsley, kale, ketchup, mini margarines, onions, peas, peppers, plums, pumpkin, spinach, squash, sweet potatoes. If you follow a healthy diet rich in beta-carotene, you do not need supplements. As mentioned above, supplements can lead to an undesirable excess in beta-carotene levels. This cannot occur if your source is from the food you eat. So, things that I probably would try to eat. I don't know apricots. I've never tried apricots. Carrots, they're not really that good. Maybe little pieces of them in your salad and a lettuce leaf salad. Chinese cabbage, never tried it. Chives, that's just like little leaves or something. Dandelion leaves. Grapefruit, no, they're too sour. Chili powder. I don't know why there'd be so much beta-carotene in that, but that's okay. Chili powder, so maybe from the peppers. There's a lot of beta-carotene in peppers. I like peppers. I like jalapeno peppers. Green bell peppers, they taste okay. I mean, they add a certain sort of tang to the thing. It's not like it doesn't take over it, and it's fresh. But the hot peppers, they seem to like actually like they bring a kick, right? They ain't just bring a little bit. They can kick your ass sometimes. Jalapenos, I really enjoy jalapenos, but I can only eat like 3 or 4. I'm such a masochist. I'll just like, if I'm craving them, I'll eat them until I'm like just in tears. It's usually after like the 5th one, I'm like, okay, that's enough. If you follow a healthy diet rich in beta-carotene, you do not. Okay, I already said all that. Smokers and beta-carotene lung cancer risk. A French study involving adult females published in the Journal of the National Cancer Institute, September 2005, found that smokers with high beta-carotene levels had a higher risk of lung cancer and other smoking-related cancers than other smokers. They also found that non-smokers with high beta-carotene intake had a lower risk of lung cancer. They found that the risk of lung cancer over a 10-year period was 18.8 per 10,000. I don't know. Further research suggested the high intake among smokers is always due to supplements and not food intake. So for some reason, if you're smoking and you're taking too much supplements, then you can actually get too much beta-carotene, and it like exacerbates. It had a higher risk of lung cancer, so it actually exacerbates the bad situations that smoking can do to your body. Studies have shown that antioxidant supplements may help prevent the degeneration of cognition. That's good, right? So carrot juice, pumpkins, sweet potatoes, spinach, carrots, spinach, sweet potatoes, carrots, collards. The most common side effect of excessive beta-carotene consumption is carotenodermia, a physically harmless condition that presents a conspicuous orange skin tint arising from deposition of the carotenoid in the outermost layer of the epidermis. So that's probably John Boehner's. I don't know if he's going to the sunbathing, tanning place for too much, or if he's just eating too many carrots. But he has an orange hue to his skin. That's why everybody makes fun of him, because he has different skin color. Oh, John Boehner and his stupid orange skin. No, I'm just... That's society. That's not me. That's not me. I'm reflecting society. I'm parodying it because that's mean. That's not... Chronic high doses of synthetic beta-carotene supplements have been associated with a higher rate of lung cancer in smokers. Additionally, supplemental beta-carotene may increase the risk of prostate cancer, intracerebral hemorrhage, and cardiovascular and total mortality in people who smoke cigarettes, have a history of high level exposure to asbestos. Beta-carotene has a high tendency to oxidize. More than most food fats, and thus may be some extent hasten oxidization and more than other food colors such as annatto. Overdose of beta-carotene, a precursor form of vitamin A, typically a vitamin sources such as carrots, is selectively converted into retinoids, so it does not cause hypervitaminosis A. However, overconsumption can cause keratinosis, a benign condition which the skin turns orange. So there's no downsides for having too much beta carotene. Probably any antioxidant, just your orange will be, your skin will be orange. That is it. The proportion of carotenoids absorbed decreases as dietary increases. Intestinal wall beta carotene. It's partially converted into vitamin A retinol by an enzyme dioxygenase. With this mechanism, it's regulated by the individual's vitamin A status. If the body has enough vitamin A, the conversion of beta carotene decreases. Therefore, beta carotene is a very safe source of vitamin A, and high intakes will not lead to hypervitaminosis A. Excess beta carotene is predominantly stored in the fat tissues of the body. Adults fat, blah blah blah. Reducing risk of breast cancer in women before menopause. Before fruits and vegetables containing beta carotene are consumed. Beta carotene seems to be especially effective for women who are at high risk of getting breast cancer, including those with the family history and those who use alcohol excessively. Treating an eye disease called age-related macular degeneration, AMD, when used with other medicines, taking 15 mg of beta carotene by mouth along with 500 mgs of vitamin C, 400 IU of vitamin E, and 80 mg of elemental zinc daily seems to prevent vision loss and worsening of AMD in people with advanced AMD. There isn't enough evidence to know if this combination works for people with less advanced macular disease. Preventing sunburn in people who are sun sensitive, however, beta carotene is unlikely to have much effect on sunburn risk in most people. Keeping a form of arthritis called osteoarthritis from getting worse. Taking beta carotene doesn't prevent it. Preventing bronchitis and difficulty breathing. Smokers, beta carotene from the diet seems to help, but beta carotene supplements do not. Reducing the risk of ovarian cancer in women after menopause. Reducing the risk of pregnancy-related death, night blindness, and diarrhea and fever after the delivery of underfed women. Preventing asthma attacks triggered by exercise. Treating a tongue disease called oral leukoplakia. Improving physical performances and strengthening in the elderly. Do your immune system a favor. Pack some more fruits and vegetables on your plate. They're loaded with nutrients called antioxidants. They're good for you. Add more fruits and vegetables of any kind to your diet. It helps your health. Some foods are higher in antioxidants than others. The three major antioxidant vitamins are beta carotene, which goes to vitamin A, vitamin C, and vitamin E. So basically vitamin A, C, and E, the ingredient of the A, beta carotene, vitamin C, vitamin E. And you'll find them in colorful fruits and vegetables, especially those in purple, blue, red, orange, and yellow hues. Beta carotene, other carotenoids. So apricots, asparagus, beets, broccoli, cantaloupe, delicious. Cantaloupe is delicious, right? Delicious. Corn, delicious. Green peppers, delicious. Turnip, collard green, mangoes, peaches, pink grapefruit, pumpkin, squash, spinach, sweet potato, tangerines, tomatoes, and watermelon. Watermelon, cantaloupe, corn, mangoes, that's some delicious beta carotene eating. And the only downside is you might just turn into an orange, right? So, or turn into a watermelon or a tomato or a tangerine, right? You are what you eat, because you seriously really are. So vitamin C, berries, broccoli, Brussels sprouts, cantaloupe, cauliflower, grapefruit, honeydew, kale, kiwi, mango, nectarine, berries, cantaloupe, grape, no, honeydew, papaya, snow peas, sweet potatoes, strawberries, tomatoes, and red, green, or yellow peppers. So yes, green peppers. Yeah, jalapenos. See jalapeno peppers, right? I like hot sauce, and I think that's what, cayenne or cheyenne peppers. Vitamin E, broccoli, carrots, chard, mustard, and turnip greens, mangoes, nuts, papaya, pumpkin, red peppers, spinach, and sunflower seeds. That's interesting. Red peppers, but not in green peppers. Sunflower seeds, you get vitamin E. Broccoli, man, none of those are good. The mangoes, nuts, vitamin E, you get some vitamin E with and out of nuts. Dang. These foods are rich in antioxidants. Prunes, apples. So apples are good, delicious, right? Apples, raisins. They said antioxidants, so that's just in general. But out of all of them, you'll get beta carotene, vitamin C and E, and all these delicious things, right? Cantaloupe and green peppers and sweet potatoes and tangerines and watermelons and did I say cantaloupe? Mango, kiwi, oranges, nectarines, strawberries, tomatoes, red, green, and yellow peppers all have vitamin C in them. So lots of vitamin C. Prunes, apples, raisins, plums, red grapes. They're delicious. Alfalfa sprouts. Okay. Onions. Okay. Strong. They're potent. Eggplant, beans. Other antioxidants can keep you healthy include zinc. This comes from oysters, red meat, poultry, chicken, right? Beans, nuts, seafood, whole grains. So you need zinc, right? You need zinc. Metal. I think you just need to take a bite of metal. Fortified cereals, dairy products. Selenium, Brazil nuts, tuna, beef, poultry, fortified breads, and other grain products. Beef, poultry, tuna, Brazil nuts. Seems like some of these essential vitamins come from meat, like you have to eat meat or something. I don't know. It's apologists, right? But I'm sure there's other ways to get those vitamins in you without actually having to eat meat. But this one woman said, you need to get some meat in you or you'll turn cranky. And I was like, huh. If you don't feel strong, you might feel weak and cranky. Ugh, my stomach's hurting. Maybe read one more paragraph. Cooking tip to get the biggest benefits of antioxidants. Eat these foods raw or lightly steamed. Don't overcook or boil them. Antioxidants are chemicals that block the activity of other chemicals known as free radicals. Free radicals are highly reactive and have the potential to cause damage to cells, including damage that may lead to cancer. Free radicals are formed naturally in the body. In addition, some environmental toxins may contain high levels of free radicals or stimulate the body's cells to produce more free radicals. Some antioxidants are made natural by the body. Others can be obtained from external sources, including the diet, dietary supplements. Laboratory and animal research have shown that exogenous antioxidants can help prevent the free radical damage associated with the development of cancer. Research in humans has not demonstrated convincingly that taking antioxidant supplements can reduce the risk of developing or dying from cancer. Some studies have even shown an increased risk of some cancers. What are free radicals and do they play a role in cancer development? Free radicals are highly reactive chemicals that have potential to harm cells. They're created with an atom or a molecule. A chemical with two or more atoms either gains or loses an electron, a small negatively charged particle found in atoms. Free radicals are formed naturally in the body and they play an important part in many normal cellular processes. At high concentrations, however, free radicals can be hazardous to the body and damage all major components of cells, including DNA, proteins, and cell membranes. Damage to cells caused by free radicals, especially damage to DNA, may play a role in the development of cancer and other health conditions. Abnormally high concentrations of free radicals in the body can be caused by exposure to ionizing radiation and other environmental toxins. When ionizing radiation hits an atom or a molecule in a cell, an electron may be lost, leading to the formation of a free radical. The production of abnormally high levels of free radicals is the mechanism of which ionizing radiation kills cells. Moreover, some environmental toxins such as cigarette smoke, some metals in high oxygen atmospheres may contain large amounts of free radicals and stimulate the body's cells to produce more free radicals. How many cannabinoids are there? A German invented the decorticator. There are two parts to the hemp stalk, the fiber and the herds, the inside pulpy crap trimline three-dimensional structure that THC mimics. Both molecules easily slipped across the brain blood area. I'm gonna give this the last one, this last hurrah. So